All right, guys, here is the warm-up to task number 2. You just learned this in the video for task number 1. So go ahead and pause your video, try it out. When you come back, we'll do them together. All right, I hope that you had a chance to try this on your own. A is pretty straightforward. I don't need to do anything to get log by itself. I'm going to undo using the inverse property. So take e to the power of on both sides, and that's that big long word exponentiate. Remember, these basically undo each other, leaving just x over here equals e squared. Just because in your book they always want the decimal answer, it seems like. So I put e squared in my calculator and I get about 7.39. So approximately 7.39. All right, we have a little more involvement in this one. Natural log is still by itself, but now I still need to undo it. And so I do the same thing I just did on A, where that cancels that out, leaving me with just 3x plus 5 squared equals e to the 4th. Now, I really feel like people get tempted at this point to multiply 3x plus 5 times 3x plus 5, but remember we're solving for x, and that's not going to help make it more simple. It's easiest to get x by itself by undoing the square with the square root, giving me 3x plus 5 equals plus or minus e squared. Now I'm going to want to subtract that 5 from both sides. So I get 3x equals negative 5 plus or minus e squared. And then divide both sides by 3. So I get negative 5 plus or minus e squared divided by 3. So if I do negative 5 just plus e squared, and I divide that by 3, one of my decimal answers is about 0.796. I obviously am going to have two answers, so my other answer is going to be negative 5 minus e squared, and that's going to be all divided by 3, and then I should get negative 4.13. It's easiest to round to the hundredths there because you can see my answer was negative 4.1296, and so where do you start rounding up? All right. Let me know in the comments or by email if you had any questions on solving basic logs. Today we're going to finish up 7.6 and the end of chapter 7 before we start trig next week by solving exponential equations. So we did this before with different exponential equations, and either we could make the bases the same, or if we could not make the bases the same, we had to undo using a log. Well, since we have a natural number e in both of these, we're going to undo using a natural log this time. But before I can undo, I need to get the exponential part. So in both of these, this part all by itself. And in A, it's not by itself. So first I need to subtract that 2 from both sides. Give me 4e to the 2x equals 14. And now I'm going to want to divide both sides by 4. So that 14/4 there might be easier if you reduced it to 7/2. You also are welcome to do the decimal of 3.5. I like to keep it in fractions. And now that the e is basically by itself, I'm going to take the natural log of both sides. So I'm going to take the natural log of that and the natural log of that. This undoes each other, just like when we were solving logs. So I get 2x equals the natural log of 7 over 2. And now all of that is divided by 2. So here's my exact answer. Now if I want to find the approximate answer, I'm going to, let me zoom in on my calculator here, clear my screen so you guys can see better. I'm going to use my natural log button, and I'm going to have 7 divided by 2 in that parentheses. And then all of that, once I have that parentheses, I can just put divide again by 2. And that gives me about 0.626. So this is approximately equal to 0.626. All right, let me zoom out a little bit so you guys can see the whole problem. You will notice on B, I don't have to do anything. E is already by itself. So I'm going to take the natural log of both sides. Remember, this undoes each other, so I'm left with x minus 2 equals the natural log of 12. Now if I add 2 to both sides, I get x equals 2 plus natural log of 12. And that is our exact answer, but I don't think the book has it like that to check. And so we would just want to try finding the decimal answer. 2 plus natural log of 12, close parentheses, is about 4.48. So this is approximately 4.48. So let me see if I can get all this on the screen in case you want to pause and finish taking any notes that you didn't get before I move on to some practice. So make sure you have a little bit of room on your piece of paper. And this is our last slide for this week. We have 2 for you to try. So again, you might need to pause, well, I'd like you to pause the video and go ahead and try these. All right, I'm hoping you had a moment to try both of these equations, and we're going to do them together now. So neither one of these had the exponential part just by itself. So here we would first need to divide both sides by 2, giving me e to the negative x equals 10. That's an x, not a y. Now I'd want to take the natural log of both sides. So I get negative x equals the natural log of 10. Divide both sides by a negative 1, so x equals the negative natural log of 10. It doesn't make the 10 negative. So remember, natural log of 10 is a number in itself. So you could come down here, use your negative, not your subtraction. Negative natural log of 10, and you would get about negative 2.3. So that is approximately negative 2.3. Remember, if you're doing any of these practice problems and you're just getting them wrong, if you don't understand what you were doing wrong and how I got the answer, or maybe I did it wrong, then just go ahead and leave me a message or something after this and we can go through it. So this one, I'm going to start by subtracting 5 from both sides, giving me e to the 3x equals 10. So this is going to be another natural log of 10 on one side. So this leaves me with just 3x equals the natural log of 10. Except for this time, it's going to be over 3. So x equals natural log of 10 over 3. and that's going to be natural log 10 divided by 3 is about 0.767 or about 0.77. So approximately 0.77. All right. Let me try to get the whole thing on my screen here. So if you guys need to get this all down, just note on the exit ticket, there's a couple different places where I say either to round to the hundredths or the thousandths. So check that out. Be reading your instructions carefully. Otherwise, it's definitely going to tell you did something wrong. Anyway, hope you have a great week. Let me know what questions you have, and I will talk to you soon.